Tesla just confirmed a major update for Optimus Gen 3 production. And hidden inside that update is a term that has confused a lot of people: Digital Optimus. At first, it sounds like marketing, but it is not. Because this one concept could completely change how robots are built, trained, and deployed at scale. Think about this. What if Tesla does not train robots in the real world first? What if they train them millions of times inside a digital environment before they ever touch reality? That is exactly what Digital Optimus could mean. And if this system works, it could solve one of the biggest problems in robotics: speed. Because today, teaching robots real-world tasks takes time, a lot of time. But Tesla may have found a way to compress years of learning into days. Today, we're going to break down what Digital Optimus actually is, why Tesla is using it for Gen 3 production, and how it could accelerate robot development faster than ever before. If you enjoy simple and powerful breakdowns of Tesla technology, robotics, and the future of AI, make sure you subscribe to the channel right now. Because Tesla is not just building a robot, it is building a system that learns at scale. Let us begin.
Finalizing the design of Optimus version 3, and that really is going to be a very remarkable robot. It will have essentially the manual dexterity of a human, so meaning a very complex hand.
What Digital Optimus actually means. Let us break this down in the simplest way possible, because Digital Optimus sounds complicated, but the idea behind it is actually very powerful. 1. A robot that learns before it exists. Digital Optimus is essentially a virtual version of the Tesla robot, a complete digital copy. Every movement, every sensor, every action simulated inside a computer before the real robot performs a task in the physical world. It can practice inside this digital environment over and over again, thousands of times, even millions of times. 2. Why this changes everything. Training robots in the real world is slow and expensive. If a robot makes a mistake, it can damage objects, it can break equipment, it can require human supervision. And every new task must be taught carefully. This takes time. But inside a digital simulation, none of those limitations exist. The robot can fail without consequences, retry instantly, learn at extremely high speed. What might take weeks in the real world could be done in hours inside a simulation. 3. Learning from data, not just experience. Digital Optimus can also learn from massive amounts of data. Tesla already collects real-world data from cars, cameras, and AI systems. That data can be used to create realistic environments inside the simulation. So the robot is not learning randomly. It is learning from real human behavior and real-world scenarios. This makes the training more accurate and useful. 4. From simulation to reality. Once the robot learns a task in the digital world, the knowledge can be transferred to the real robot. This is called sim-to-real transfer. For example, if Digital Optimus learns how to pick up objects, open doors, use tools, clean surfaces, the real Optimus robot can perform those same actions almost immediately, without starting from zero. 5. Why Tesla is doing this for Gen 3. Tesla wants Optimus Gen 3 to handle many different tasks, not just one or two. We're talking about factory work, household tasks, repetitive daily actions. Teaching all of that manually would take years, but with Digital Optimus, Tesla can train robots at scale, faster than any traditional robotics company. Now, here's the big question. If Tesla can train robots this fast, how much faster can they reach mass production? Before we continue, make sure you subscribe to the channel if you enjoy simple explanations of Tesla AI, robotics, and future technology.
Now here is where things become truly powerful. Because Digital Optimus is not just about training robots, it is about speeding up the entire production pipeline. And this is where Tesla could gain a massive advantage. Number 1. From years of training to days. Traditionally, teaching robots new tasks is a slow process. Engineers must program movements, test in real environments, fix mistakes manually, repeat the process again and again. This can take months or even years for complex tasks. But with Digital Optimus, Tesla can simulate those same tasks digitally. Instead of training one robot at a time, Tesla can train thousands of virtual robots, running simultaneously, learning at high speed. What used to take years could now be compressed into days or weeks. Number 2, parallel learning at massive scale. This is the real breakthrough. Digital Optimus allows Tesla to run parallel simulations. Imagine this. One virtual robot learns how to cook. Another learns how to clean. Another learns how to organize objects. Another learns how to work in a factory, all at the same time. And all of that knowledge can be combined and transferred to real robots. This is something traditional robotics simply cannot do at scale. Number 3, faster updates across all robots. Here is another powerful advantage. Once Tesla improves something in Digital Optimus, that improvement can be shared instantly. Every robot can receive the update. No need to retrain each robot individually. This is similar to how Tesla updates its cars with software, but now applied to robots. This means faster improvement cycles, better performance over time, continuous learning across the entire fleet. Number 4, reducing production risk. Training robots in the real world carries risks. Mistakes can cause damage to equipment, safety issues, production delays. But in a digital environment, Tesla can test everything safely. Before deploying robots into factories or homes, Tesla can ensure tasks are optimized, movements are efficient, errors are minimized. This reduces risk during real-world deployment. Number 5, why this matters for Gen 3. Tesla wants Optimus Gen 3 to be more capable, more reliable, and ready for real-world tasks. Digital Optimus makes this possible because instead of slowly improving one robot, Tesla can improve an entire generation of robots at once. Now here's the big question. If Tesla can train robots this fast and at this scale, what does that mean for the future of robotics compared to competitors? Before we continue, make sure you subscribe to the channel if you enjoy powerful breakdowns of Tesla AI and robotics. Number 1, most robotics companies move slowly. Traditional robotics companies follow a very different approach. They usually build physical robots first, test them in real environments, manually improve performance, repeat the process again. This process is slow, very slow, because every improvement requires physical testing, human supervision, time-consuming iteration. That means progress happens step by step. Number 2, Tesla is building a software-first robot. Tesla is taking a completely different path. Instead of focusing only on hardware, Tesla is treating Optimus like a software problem, and software scales. Digital Optimus allows Tesla to train robots in simulation, improve them through software updates, and deploy improvements instantly. This is the same strategy Tesla used with its cars, and it worked. Now Tesla is applying it to robots.
3. Data is Tesla's secret weapon. Here is something most people overlook. Tesla already has access to massive real-world data from cameras in vehicles, AI vision systems, real-world driving environments. This data can be used to create realistic simulations. That means Digital Optimus is not learning in a fake world. It is learning from real human environments. This gives Tesla a major advantage because better data means better training. 4. Speed becomes the ultimate advantage. In technology, speed often wins. The company that learns faster improves faster, and the company that improves faster dominates. If Tesla can train robots faster, update them faster, deploy them faster, then competitors may struggle to keep up. Because while others are testing one robot, Tesla could be improving thousands at the same time. 5. From cars to robots, the same playbook. Tesla already proved this model with electric vehicles. Continuous updates, data-driven learning, software improvements over time. Now it is repeating the same playbook with Optimus, but the impact could be even bigger. Because robots are not just vehicles, they can perform hundreds of different tasks. Now we reach the final question. If Tesla combines Digital Optimus with real-world robots, how close are we to seeing these robots in everyday life? Before we finish, make sure you subscribe if you enjoy simple and powerful breakdowns of Tesla technology and AI. Is Digital Optimus the key to making robots mainstream? Now we reach the final and most important question. Is Digital Optimus just a smart engineering tool, or is it the missing piece that finally brings robots into everyday life? Because for years, humanoid robots have existed, but they have never scaled. They have never become part of normal daily life. And the reason is simple. They could not learn fast enough. 1. The real problem was never hardware. Most people think robotics is limited by hardware, motors, sensors, actuators. But Tesla is showing something different. The real limitation was learning speed. If a robot takes months to learn one task, it will never scale to millions of units. But if a robot can learn thousands of tasks quickly through simulation, everything changes. 2. Digital Optimus solves the scaling problem. This is what Digital Optimus is really about: scaling intelligence. Instead of teaching one robot slowly, Tesla can train an entire fleet digitally, then deploy that knowledge instantly. This means faster learning, faster improvement, faster deployment, and most importantly, faster real-world usefulness. 3. From factories to homes. The first place we'll likely see Optimus is in factories. Repetitive tasks, controlled environments, predictable workflows. But once Digital Optimus accelerates learning, expansion becomes possible. From factories to warehouses, retail environments, eventually homes. Tasks like cleaning, organizing, assisting elderly people, performing daily chores, all become possible as the robot learns more. 4. The timeline question. Now let's be realistic. This won't happen overnight. Even with Digital Optimus, Tesla still needs to refine hardware, improve real-world reliability, reduce cost. But the direction is clear. The biggest barrier, which is slow learning, is now being attacked directly, and that could shorten timelines significantly. Final thoughts. Digital Optimus is not just a feature, it's a strategy to turn robotics into a scalable technology, just like Tesla did with electric vehicles. If this system works as expected, Tesla may not just build robots, it may build a platform where robots continuously learn, improve, and expand their capabilities over time. And that's when robots stop being experiments and start becoming part of everyday life. If you found this breakdown helpful, make sure you subscribe to the channel for more deep dives into Tesla AI, robotics, and future technology. Also, leave a comment below and tell me your opinion. Do you think robots like Optimus will become common in homes within the next 10 years? And if you want to go deeper, watch the next video where we break down Tesla Bot Gen 3 hardware upgrades and what makes it closer to human-level capability. Thanks for watching, and I'll see you in the next video.